This will be our test setup for the experiment today, where we'll be burning wood using 8,000 volts. Here I have my extension cord. Here I have a Variac, which lets me divide that incoming 120 volts to a smaller voltage. There's also a lighted switch here. Then I have my transformer for a neon sign. This will multiply my voltage by about 66. Here's a schematic of our test setup that we'll be using today. We have 120 volts AC source that's coming from the extension cord. Then I have a switch coupled with a potentiometer here, and this is modeling the Variac, which can divide the 120 volts AC coming in to be a smaller ratio. So that's the way you can control the magnitude. It also has a lighted red switch here, modeled by this switch. That output is then fed to my transformer, which has a switch of its own, and it has a transformer inside of it, which will transform a voltage with a 66 multiplier. So if I have 100 volts coming in, I would have 6.6 thousand volts coming out. But I have 120 coming in, so I'm going to have about 120 coming in and about 8,000 or so leaving. So if I connect that, connect this, then we take a look at the output scaling. We can see that we have a little bit over 5,000, 6,000 on the outputs here. And the input is going to be much smaller than that. Can't even really see it move. So let's reduce that. About 120 volts in the output, on the input. So roughly we're going to have about 8,000 volts AC being applied across the wood. The wood I've modeled here with a 10 mega ohm resistor, but after I add the salt water, that resistance is going to lower so that I can actually start conducting some electricity across the wood and burning channels into the wood. Also, it seems that the burned wood is a much lower resistance, which is why it continues to burn in the channel that it's already started. So you'll see it snake out. Okay, let's take a look at the next thing. Here's the Variac, which is used to control the 120 volts in. The dial on the top controls what fraction that will leave. There's also a lighted switch and a 3-amp fuse. Here's the neon power supply. 120 volts AC come in. A dial indicate what fraction that leaves. I set it to max, which means 8,000 volts leave this power supply. Here's an example of when too much salt water is used to cover the board. The water soaks into the wood, which prevents it from burning. And here's an example of how to do the process correctly. Here's a sponge with a bowl of salt water. Add as much salt as you want. I prefer to use too much salt. Cover the board with a very light layer of salt water. You don't want to soak the wood too much, otherwise it won't burn. Insert the probes and then turn on the power supply. You can see that fairly quickly, within a second or so of turning on the switch, it turns on. In both of these cases, the burning stopped because the salt water evaporated, which increased the resistance to be too large, so the burning would not continue. I'm going to speed it up, turn off the lights, and just show you the process. It'll take about a minute or so. Final result has a very interesting design with main channels and small tributaries amongst those channels. Sand it smooth, apply a nice finish to it, and you get a very nice design that even has some texture. The design is about 1/16 of an inch deep on some of the major channels.